Okay, so we'll attempt to solve this. So we have a wheel of diameter of 80 millimeters, which is rolling on some concave surface with a radius of 160 millimeters, and a point P is located 30 degrees from the positive x-axis in a clockwise direction on a rolling circle. We want to trace out the path of the point P, which is located on the rolling circle, and we want to do this for 1.5 of a revolution. So let's see how we tackle this issue. So I'll be using a software for demonstration purposes. So you will follow along with your drawing board and with your drawing instrument. So what we first do is draw the directing circle, and then would continue from there. So the directing circle has a radius of 160. Once we are done, we can now draw some diametral line which goes through the center. Okay, so I am going to use this as my diametral line. So you just draw a diameter which divides, of course, will divide the circle. Okay, and then we can use the principle of tangencies to locate the center of the rolling circle. So we know that the two circles are going to be tangential at this point. So we can actually use an arc. Okay, so from this tangency point, we know that the radius of the rolling circle is 40. So this arc then will give us the center of the rolling circle. So from this intersection, we can now draw this circle, and that will be our rolling circle. All right, so what we'll do next is let's first locate our point P. So we know that the point P is some 30 degrees from the horizontal in the uh the positive x-axis. So let's locate the x-axis. Now obviously the x-axis is going to be 90 degrees away from the diameter. So let's make sure that we have the 90 degrees. So you would use your protractor to measure the 90 degrees so that you make sure that this x-axis or the horizontal is 90 degrees away from the given diameter or the initial diameter that you drew. For me here in the software, I will make sure that this angular measurement, so from here to there, I need to make sure that's 90 degrees. So that is 90 degrees. So I've constrained these two to be 90 degrees. And then if I measure 30 degrees from this 90-degree line, that will then give me the position of the point P. So with your set square, either with your set square or with your protractor, you should be able to get the 30-degree line measured from the positive x-axis in the clockwise direction. Okay, so for me, and that is 30 degrees. Okay, so my point P will be located here at this intersection. So that is where P will be located. Okay, so now that I have P located, what I want to do is I want to divide the circle into 18 equal parts. And we are doing 18 because we have 1.5 of a revolution. Okay, so let's do that. I'll clear some of these arcs and dimensions which were used for demonstration purposes. So you would have to use your compass or your set square to do the divisions. I will take advantage of the capabilities of the software to do the divisions. Now I will label the divisional lines as is required. Okay, so we'll go around it for the first time. So our point P, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 11. And then we begin the other half. So 12, 13, 14, 15, 16, 17, and then back to 18. So that is 1.5. Let's now compute the swept angle or the included angle and then draw those as well. We know that the included angle is given by the formula small r over big R, all of that multiplying 360. So 40 divided by 160 in this case, and all of that is multiplying 360. So we get 90 for one revolution. And mind you, we are doing 1.5 revolutions, so this multiplied by 1.5. So the included angle is 135. So we'll measure the 135, and then we'll have to divide the 135 into 18 increments. So let's calculate that divided by 18, and we get 7.5 per angular increment. Okay, all right. So let's go ahead and then draw that. Now obviously you would use your compass to measure the 135 and then draw your line with your straight edge and your pencil. Again, I'll take advantage of the software. All right. So we measure the angle here and we see that we have 135. So you make sure you also have that 135 drawn in. Okay, so what I'll do next is I'll draw my central arc, or the arc that goes through the center. Let's draw that first before we do the angular divisions. So with your compass, of course, using this point O here as center, you open to C. So we can label that as C. And then this point here as O. Okay, so now we can draw the central arc. So for my central arc, so from here all the way to the center, this is my central arc. And now I'll divide this into 18 angular parts. So like we calculated 135 divided by 18, that gives us 7.5 degrees. So you use your protractor to do the divisions and then draw using your ruler and pencil. I'm going to use the software to do that. Okay, so this is what we have. I'm going to label the centers from C all the way to C18. Have the centers labeled. What we'll do next is for us to draw the arcs which proceed from the divisional lines on the rolling circle through the directing circle. So with point O as center, our radius is going to be 0.1. And then we draw all the way to C, right, to C8. And that is our first divisional line or divisional arc. With O as center, now we start at 2, and then we draw all the way up to this point. and then we go to 3 with O as center. We open to 3, and then we do that. Now what you realize is that 3 will definitely go through 6 and 8. Okay, so 3, we open to 3, and then we draw through. Now the next one will be from O to 4, and obviously that has been captured. That actually is the directing circle itself, so we leave that. And then let's go to 5. So from O we go to 5. Now what you see is that 5 will go through 3. That also means that 6 is going to go through 2, and then we continue like that. So next we go to 7, and 7 will go through 1. So O as center. Next we are going to 7. So make sure you have O as center. You open to 7, and that takes us through 1. So next we have to go to 8. So it's obvious that 8 will take us through the point P, and then all the way to that other side. And then from here we go to 9. 9 will go through 11. So O as center, and then 9 through 11. Okay, great. And then finally we have 10. And that is that. Okay, so we are ready to go on to the next phase. So what we'll do is we take this measurement from C to P, and we know that from CP is the radius of the rolling circle, which is 40. And then we move to center 1. We stand at center 1, and we describe an arc. We describe an arc on the 1/7 divisional arc. But before we proceed, I want to make a little adjustment. So, okay. So with your compass, you can take CP, and CP in this case is going to be 40. And then we stand at center 1. So the center required is going to be center 1, and make sure you are standing at center 1. And what you are looking for is the 1/7 divisional line, which is this one right here. Now the radius CP is 40, and then we can describe an arc on the 1/7 divisional line like this. And this is going to be the point or the position of the point P when we move to center 1. So we now can label this as P1, C2. We are going to draw an arc on the 2, on a 2/6 arc found somewhere here, and the radius is 40. Then we can draw an arc which goes that way. So that's our point P2. So we move on to the third center, which is C3. And then we're still using the same radius, which is 40. That will be P3. So from the fourth center point, the radius remains 40. And that's P4. Okay, so from the fifth center, we are going back to the 3/5 arc somewhere here, and the radius is still 40. So I'm going to use a different color. So 40. Okay. So the one in red, that's C5. So that will give us P5. Okay, so now we want to draw, or we want to locate the fifth point. So from center 6, we look for the 2 6 arc, and then we're still using our radius of the rolling circle, which is 40. Then we can place an arc there which indicates where point 6 is going to be. So you'd have to label the point on your drawing. So from the 7th center, now we are looking for the 1/7 arc with radius of 40. So that's P7. From the 8th center, we are looking for the 8th arc with a radius of 40. And that's our 8th point. Now from the 9th center, we are looking for the 9th arc somewhere there. Radius of 40. And that's our 9th point. And then from 10, we should be somewhere there on the 10th arc. So 40. And then, so from the 11th center, we are looking for the 1/11 arc, which is this one. So the radius is still 40. From the 11th center, we are looking for the 11th arc with a radius of 40. And that is the 11th arc. And then from the 12th center, we are looking for the 12th arc, which happens to be the same as the P arc, that is the same as the 8th arc as well. Radius remains unchanged at 40. So from the 13th center, same radius of 40, I'm looking for the 13th arc, which is the one arc. All right, and then so from the 14th center, I'm looking for the 214 arc. Radius is still 40, and that is P14. So from the 15th center right here, I'm looking for the 15th arc, which is this one. Radius still remains unchanged at 40. And that is my 15th arc. And now I go to center 16. So from center 16, I am going to the 16th arc, which is also the fourth one. Radius remains unchanged, and that should coincide with the directing circle. Okay. All I'm doing is just editing the labels. So from center 17, I need to draw an arc on the 17th arc, and the 17th arc is also the same as the 5th arc. So radius is still 40. All right, and that point will coincide with the 15th point. So that will be 17. And I finally would have the last one, which is 18. So from 18, from the 18th center, I'm going to be on the 18th arc, and the 18th arc is also the 6th arc, which should be this one. Radius is still 40. Okay. So you can use your drawing instrument, you can use your French curves to join these points together. So we'll start from P through P1, P2, P3, and then P4. So that is going to be our first part of the arc, or the first part of our hypocycloid. And then from point 4 we go to point 5. Mind you, point 3 and point 5 almost coincides. And then to point 6, to point 7, to point 8, point 9, point 10, 11, 12, 13, 14, 15, and then 16. So that is the next section. And the last section is going to be a continuation. So from 16 we come to 17, and 17 is coincident with 15, and then lastly we end at 18. Okay, so this will be our solution.